Okay, here's homework 5.5, adding and subtracting rational expressions. This is the second day where we're dealing with binomial denominators. This is number 4. Okay, so if you notice here, I have two fractions, and the operation between them is addition. Well, in order to add two fractions, they must have the same denominator. So, the first denominator here is an x plus 5. That means that everybody is going to end up having to have an x plus 5 in order to have a common denominator. There is no factoring that I can do, nothing that x and 5 have in common, so I'm just going to put parentheses around it and say that, okay, x plus 5 is one of my factors here. Okay. The second fraction has a denominator of 3x plus 3, and I see that they have a 3 in common. And when I pull a 3 out, I get an x plus 1. Okay? I'm factoring out this denominator to see if, by chance, I end up with an x plus 5, a similar factor to the other denominator. Unfortunately, I don't. So what I need to do now is figure out, okay, what does everyone need to have in common in order to have the same denominator? Okay, and what I'm going to do is I'm going to replace my original denominator in the second fraction, this 3x plus 3. I'm going to mark that out and say that in its spot I'm going to just leave a 3 and an x plus 1. Okay, so my common denominator that everybody has to have. The first fraction, it looks like everyone has to have a x plus 5 because he has it, so everyone has to have it. Okay. If I look at my second fraction, well, he does not have an x plus 5, but he instead has two other factors that everybody needs to have. There is a x plus 1, so I'm going to write that after this here, okay, in my CD spot. And then he also has a 3 on the outside alone, so I'm going to put a 3 on the outside alone there. So in order for them to have the same common denominator, everybody has to have a 3 times the x plus 5 times the x plus 1. So step number 3 is to figure out what do they each need to be multiplied by in order to have that common denominator. Okay, and remember we do the same thing, top and bottom, so that we're not changing its value, we're just changing how it looks. Okay, so the first fraction has an x plus 5. What he is missing is this 3x plus 1. So I'm going to put that in the top and the bottom. And I will multiply that out here in just a moment. The second fraction, the only thing he's missing is the x plus 5. So I'm going to put that in the top and the bottom. Okay. And now what I'm going to do is I'm going to do step number 4 that says multiply out the tops. So the bottom, I'm just going to rewrite it. I know that I have the 3 factors for my common denominator. Okay. Now for the top, I have 3 different factors. Multiplication is commutative. It doesn't matter the order I multiply those 3 things in, as long as I multiply all 3 things together. So I'm going to actually start by doing the 3 times the 3. And I'm going to say that this is 9. And then I need to multiply that by x plus 1. So the top is going to become 9x plus 9. That is the numerator for the first fraction. Okay? I have a plus symbol that I'm going to bring down. My denominator of my second fraction now matches my first fraction when I multiply it by an x plus 5. And I need to distribute the 4 into the x plus 5 for the numerator. So I get 4x plus 20. Okay? Now my fractions have the same denominator. Now I can put them together into one large fraction. Notice that I do not multiply or FOIL out my denominator because I might need to go back and factor it later, so I'm just going to leave it pulled apart. The top here, I have 9x and I need to add 4x. That gives me 13x. I have 9 and I need to add 20. So I get plus 29. That is what it looks like when I put it all together as one fraction. Now I need to see if I can simplify this fraction. 13 and 9 happen to both be prime. They have nothing in common, and there are no x's in common. There is nothing that I could factor out of the top to cancel with the bottom. So this is actually my final answer.